So collinear force system, concurrent force system, and parallel force system. So beyond that, what we have? So we have types of loads, means types of forces. So what type of forces we need to study? Concentrated load, which is also called as point load, then UDL, that is uniformly distributed load, and UVL, that is uniformly varying load. And when it comes to moments, we only two types, that is clockwise anti-clockwise moment and a couple, right? So let's proceed towards types of forces. So first type of force is, right, so we have collinear force or collinear force system. So what is collinear force system or collinear force? The forces which are in same line of action, ज्यांची line of action ही same असते. And we have two categories. The forces will act towards each other or it will act opposite to each other, right? So you can observe in this example, this is a tug of war, the game which is named as tug of war, in which though there are four students or four boys on left side and three boys on the left side and four on the right side. So these two groups are pulling the rope in opposite direction. म्हणजे फोरची डिरेक्शन कशी आहे? Opposite to each other. Left team is pulling towards left, right team is pulling towards right, but the line of action of force is along the rope. म्हणजे त्यांची डिरेक्शन जरी वेगळी असली पण फोर्स कुठे लागतोय तो ती जी दोरी आहे रोप, त्या रोपच्या लाईन मध्ये तुमचे सगळे फोर्सेस आहे, right? So this kind of system is called as collinear force system, or the forces are called as collinear forces. So moving to second, that is concurrent force system. So what is concurrent? When the forces meets at a point. You can observe this lower image in which the five forces are acting at a single point but are acting away from the body, right, from the origin or O point. Whereas in case of second figure, there is upper image, all the three forces or three vectors are acting towards the origin or towards the O point, right? So this is concurrent force system, means forces meets at a single point. Then parallel force system. What is parallel? When lines of action of forces are parallel to each other. म्हणजे तुम्हाला बघायचं काय आहे? फोर्स बघायचा कसा आहे? In this figure, what type of force it is, or which forces are available or shown in the image? We have 600 Newton, 700, 500 and 850. But when we focus on the line of action म्हणजे काय? फोर्स ची डिरेक्शन कुठले ते फक्त बघायचं. 600 न्यूटन इज इन वर्टिकल डिरेक्शन, 700 अगेन इन वर्टिकल डिरेक्शन, अप आहे डाऊन आहे ते बघायचं नाही, डिरेक्शन त्याची बघायची. So 600 vertical, 700 vertical, 500 vertical and 850 is also acting in vertical direction, right? So lines of action or line of action of each force is vertical. आणि आपल्याकडे चार फोर्सेस आहे, means four vertical lines are there, hence we can conclude that these four forces are parallel to each other. Therefore this system or type of force system is parallel force system. ठीक है? So we have concurrent, collinear and parallel force system. So these things are related to the force system. Moving to force, now we have types of force. First is concentrated load or concentrated force, which is also called as point load. मग फोकस कुठे करायचं? नावावरती फोकस करायचं. Concentrated load means point load, means total force acts at a single point. You can observe the flamingo. Full weight of the flamingo is acting on the ground or on the sand through his one leg only. बरोबर आहे? म्हणजेच काय, जेवढं काही वजन असेल, कुठले कुठले सगळे फोर्सेस असतील, टोटल लोड इज ऍक्टिंग ऍट अ सिंगल पॉइंट. असा जो पॉइंट असेल, एखादा लोड असेल, तो एकाच पॉइंटला ऍक्ट होतो. सो इट इज कॉल्ड एज कॉन्सन्ट्रेटेड लोड और पॉइंट लोड, राइट? So second one, that is uniformly distributed load. नावावरती फोकस करायचं, सगळं तुम्हाला इझी जाईल. युनिफॉर्मली डिस्ट्रीब्युटेड लोड. डिस्ट्रीब्युटेड मीन्स द लोड इज डिस्ट्रीब्युटेड along length, along area, along volume. Currently we are dealing with along length only, right? So along length, when the load is distributed म्हणजे काय, जो टोटल लोड आहे तो डिस्ट्रीब्यूट केलेला आहे इव्हनली और युनिफॉर्मली from A to point B. So this is termed as UDL, that is uniformly distributed load. Means intensity of load. Intensity म्हणजे काय, force magnitude. It is same throughout the length. From A point to B point it is same, that is W per length. So this is uniformly distributed load. Now moving to third, uniformly varying load. युनिफॉर्म तर आहे बट इट इज व्हॅरिंग, युनिफॉर्मली व्हॅरिंग. म्हणूनच तिकडे तुमचं ट्रायंग्युलर इमेज आलंय बघा. ऍट द एक्स्ट्रीम लेफ्ट साइड वी हॅव 0, एक्स्ट्रीम राइट वी हॅव 0, but at the center we have WO, means full magnitude is at this or at a distance of L by 2 and 0 at the extreme end. मग straight line what indicates? It indicates the uniform nature. ठीक है. So this is about uniformly varying load. So concentrated load, UDL and UVL. So this was about types of system, that is force system and load. Now we have two types of moments. First we have clockwise moment and anti-clockwise moment based on the sign convention. But what is a moment? It is a rotational effect. ठीक है. म्हणजे काय, you can observe spanner is attached to the nut at the point M, but where is the force? Force is at point F. पण यांनी फोर्स इथे लावलाय, ऍक्शन कुठे झाली, M ला झाली, राइट? सो डिस्टन्स D is involved. So this force is creating a rotational effect of this nut through the spanner by means of a distance of D, means F into D. म्हणजेच आपण काय म्हणतोय, force into distance, that is nothing but your moment. So what is moment? Moment is a rotational effect, right? And last we have couple. What is couple? Two equal and opposite forces forms a couple. You can observe the images. For example, if you need to tighten the screw or to loosen the screw, we apply a equal force but in a rotational manner, right? Either you are moving the screwdriver in the clockwise direction or in the anti-clockwise direction. With the help of your fingers, you are going to apply equal forces but in opposite direction. Similarly, to open or to close the water tap, again we are using two fingers, but we are applying, what we need to focus on or observe is that we are applying two equal and opposite forces, right? So this is nothing but a couple. So this was about force system, types of forces and moments. So now moving to another segment, that is resolution and composition of forces. It's very easy again. See, focus on the first statement. Resolution means representation of a force into number of components. Read second line. Composition means representation of number of forces into single force. आता याच्यात लक्षात ठेवण्यासारखं काय आहे, वी हॅव सिंगल फोर्स, त्याला जेव्हा तुम्ही डिवाइड करणार इन टू फोर्सेस, थ्री फोर्सेस और नंबर ऑफ फोर्सेस, व्हॉट वी आर गोइंग टू कॉल इट ॲज रिझोल्युशन. एकाचे तुम्ही तुकडे केले नंबर ऑफ, यू विल कॉल इट ॲज रिझोल्युशन. इट्स मिरर इमेज और अपोजिट इज कंपोजिशन. व्हॉट इज इन्क्लुडेड इन कंपोजिशन? रिप्रेझेंटेशन ऑफ नंबर ऑफ फोर्सेस इनटू सिंगल फोर्स. म्हणजे खूप सारे फोर्सेस आहे, त्याचा तुम्ही एकच इफेक्ट दाखवणार आहात, देन इन दॅट केस यू विल कॉल इट एज कंपोजिशन. इट्स व्हेरी इझी टू अंडरस्टँड. एकाचे तुम्ही तुकडे केले, इट इज रिझोल्युशन. सगळ्या तुकड्यांचा तुम्ही एक फोर्स केला, इट इज कंपोजिशन. right? So this was resolution and composition. Now we have the main segment, that is support reactions. So let us see. So we have two categories, that is types of support and number of reaction. हे सगळ्यांना माहितच असेल. Just again we will revise. So we have basic three types of supports. Step by step लक्षात ठेवायचं. We have three types of supports. Which supports we have then? We have fixed support, roller support and pin support. Pin म्हणजे काय? Hinge support. Okay, so hinge, roller and fixed. Now first focus on roller support. ठीक है? So what we have in roller support? So you can observe one roller support or one roller or wheel is provided to the support. ठीक है? So here we can observe a triangular support is provided with a wheel below it. यानी होणार काय नेमकं की जेव्हा आपला हा बीम आहे, you can move that beam to the left hand side or to the right hand side. Correct? Means left hand side and right hand side translation is allowed or movement is allowed, पण तो वर खाली करू शकत नाही. करेक्ट आहे? Therefore we have one vertical reaction, hence roller support as one reaction. सगळ्या मुलांना रिएक्शनच्या टाइप मध्ये आणि क्वांटिटी मध्ये नेहमी कन्फ्युजन असतं, त्यामुळे सिक्वेन्स असा लक्षात ठेवायचा. रोलर सपोर्ट आहे त्याला एकच रिएक्शन कुठे असणार? रोलरचा जो सपोर्ट आहे म्हणजे हा हॉरिझॉन्टल जो तुम्हाला दिसतोय खाली डॉटेड लाईन केलेला, त्याला परपेंडिक्युलर नेहमी असणार. So for this condition the support is horizontally placed, so we will be having vertical reaction. समजा रोलर सपोर्ट मी असा एक इकडे केला, लेफ्ट साइडला केला, कडेला केला, सो इन दॅट केस युअर सपोर्ट रिएक्शन विल बी इन हॉरिझॉन्टल डिरेक्शन. ठीक आहे? मग तुमचा बीम कसाही ठेवा, आपल्याला फोकस कुठं करायचंय? जिथे तुमचा सपोर्ट आहे त्या सपोर्टच्या प्लेनला फोकस करायचा. सो रोलर सपोर्ट हॅज ओनली सिंगल रिएक्शन. Moving to second, we have pin support, which is also called as hinge support. So here again, what is hinge? हिंज सगळ्यांनी बघितलं असेल, नसेल बघितलं तर परत सांगतो. दरवाजा जो असतो आपल्या घरातला, भिंतीला दरवाजा जोडलेला असतो बाय मीन्स ऑफ अ हिंज. म्हणजेच काय? इट अलाउज द मुवमेंट और रोटेशन ऑफ डोअर. एकदा आपण डोअर ओपन पण करतो आणि क्लोज पण करतो बाय मीन्स ऑफ हिंजेस. मग आपल्याला लक्षात घेण्यासारखं काय आहे की जेव्हा हिंज सपोर्ट असतो तेव्हा आपला बीम आपण काय करू शकतो? तो रोटेट करू शकतो. मीन्स currently it is placed in horizontal direction, you can also rotate the beam in vertical direction. म्हणजे तुम्ही इकडे पण ठेवू शकता, लेफ्टला पण ठेवू शकता, राईटला पण ठेवू शकता. So you can rotate the beam, therefore rotation is allowed, पण तुम्ही तो व्हर्टिकली मूव्ह करू शकत नाही आणि लेफ्ट हँड साइडला राईट हँड साइडला पण मूव्ह करू शकत नाही, as we can do in the case of roller support. Therefore hinge support has two reactions. Which are those two reactions? Vertical and horizontal. So support 1 roller, one reaction. Support 2 hinge support, two reactions. Now moving to third, that is fixed support. Okay, so in case of fixed support काय काय होऊ शकतं? We neither can move to the left hand side, right hand side, nor in vertical direction, and also we cannot move or rotate the beam because it is fixed. तो आता तुम्ही रोटेट पण करू शकत नाही. मग जे तुम्ही करू शकत नाही ती तुमची रिएक्शन. सो व्हॉट वी कॅनॉट डू? तुम्ही लेफ्ट हँड साइड राईट हँड साइडला मूव्ह करू शकत नाही, मीन्स विल बी हॅव्हिंग रिएक्शन इन हॉरिझॉन्टल डिरेक्शन. Also we cannot move in vertical direction, so we will be having vertical reaction. And at third, we also cannot rotate the beam, hence we have a reaction in terms of a moment. Therefore for fixed support we have three reactions: horizontal, vertical and moment. Okay, so what you need to understand or what you need to keep in mind is roller support one reaction, hinge support two reaction and fixed support three reaction. सगळ्या गोष्टी सिंपल सिंपल लक्षात ठेवायच्या, राईट? सो This was about supports and reactions. And last we have types of beam. It is again very easy to understand. When we have a beam in which we have one fixed support and one free end at the other, it is cantilever. When it is rest simply over the support, simply supported म्हणजे काय, one hinge, one roller, it is simply supported. When we have hanging portion, you can observe in third image or C image, that is overhanging. So in this particular case, we have two overhang, one on the left hand side, one on the right hand side. अशी कंडिशन नाही की तुम्ही दोन्हीकडे ओव्हरहँग असले पाहिजे, तुमचे एका साइडला पण ओव्हरहँग असू शकतो. And when we have more than two supports, it is called as continuous beam. And then we have fixed supported beam, means left hand side ला पण fixed support आहे, right hand side ला पण fixed support आहे. And last we have simply supported cantilever. It is also called as propped cantilever, right? So this was about the main things which are needed as a part of your prerequisites. So let's revise the things. So what we have studied, that is various force system, means collinear, parallel and concurrent. Then types of forces, point load, means concentrated, UDL and UVL. Then types of moment, clockwise, anti-clockwise and couple. Then resolution and composition of forces. So what is resolution? एका force चे तुकडे करणे, means representation of single force into number of components. And composition means representation of number of forces into one force. Then of course types of beams, cantilever, simply supported, fixed beam, composite beam or continuous beam and fixed beam. And at last we have seen types of supports and reactions. So let's see some numerical or examples on support reactions. But before that, we have a short clip so that you can understand it very well. So let me share it.
In this video, we'll be learning about types of supports used in beams and reaction produced in them on loading. First of all, let us understand what a reaction is. Let us consider a block of concrete lying on the ground. In this arrangement, the block is applying a force of mass times acceleration to the ground. In return, the ground applies equal and opposite force as per Newton's third law of motion. This force is called reaction. Now let us see various types of supports and reactions they generate when applied by force. First we will see a simple support. In this support, the structural member simply rests on an external frictionless surface. This kind of support allows rotation and horizontal movements, but not vertical motion. Hence it produces only one reaction to the applied force, which is perpendicular and away from the surface. Next we will see roller support. This support has wheels on the bottom and a hinge to attach members in it. The surface can be horizontal, vertical or sloped at any angle. While assuming this support in calculations, all surfaces and the hinge are assumed to be frictionless. This kind of support allows lateral movement and rotation but does not allow vertical motion. Hence it produces a vertical reaction to the applied force. Value of moment will be 0 at roller support as it allows rotation. A roller support is generally represented in mechanics in this way. This kind of support is found in large bridges, which allows thermal expansion and contraction of the bridge. Next comes pinned support. This support is fixed at bottom and has a hinge to attach members in it. The surface to which support is attached can be horizontal, vertical or sloped at any angle. This kind of support allows only rotation and restricts horizontal and vertical movements. Hence it produces two reactions to the applied force, one in horizontal direction and other in vertical direction. Value of the bending moment will be 0 at pin support as it allows rotation. Pinned support is generally represented in mechanics in this way. This kind of support is also found in bridges and trusses. So will the pin support or roller support always allow rotation? The answer is not necessarily. If the roller or pin support act as intermediate support in continuous beam, then it will resist the rotation. In this illustration, the continuous beam is loaded uniformly. Dashed lines show the deflected shape of the beam where end support allow rotation but middle support resists the rotation, and zero moment at the ends and some value of moment in the middle. Next we will see rigid or fixed support. This kind of support restricts any kind of motion, hence we will see all three reactions, which are horizontal reaction, vertical reaction and a moment. This type of connection is used in concrete frame structure or in this case a cantilevered beam. They are represented as a single line for structural members and a hashed vertical line for fixed support.
Okay, so this was about all the theoretical concepts related to prerequisites. So let's solve some numerical on support reactions. So example 1, it deals with support reaction of cantilever beam, right? So let us see what we have today is calculate the support reactions of a cantilever beam loaded as shown in figure. So just observe the figure. So what data is included or what they have given us is a cantilever beam. Then how to identify cantilever beam? We have this single support at point A and we don't find any other type of support from B towards E, and at E it is free from any type of supports, means it has single support and that too again fixed on the left hand side, hence it is a cantilever type of beam or cantilever beam. Now think about forces. We also seen the types of forces. So observing first force that is acting at point B, it is 3 kilonewton point load or concentrated load, right? Moving to point E, again we have one point load, that too of magnitude 1 kilonewton. And when we observe the portion CD, we have a load which is having uniform intensity, means load is distributed evenly or uniformly from point C to point D. So this is our UDL. So for that we need a free body diagram. फ्री बॉडी डायग्राम म्हणजे काय, जे सपोर्ट दिलेले असतील त्याच्यावर जी आपल्याला अननोन क्वांटिटी तिथे रिप्रेझेंट करायची. सो ऍज वी हॅव सीन अ फिक्स सपोर्ट हॅज 3 reactions or 3 support reactions, that is vertical reaction, horizontal reaction and a moment. Therefore we have replaced the point A with 3 reactions. So we have VA, HA and MA. So fixed support, 3 reactions are required or 3 reactions are present. Now to find the 3 reactions, we need 3 equations, correct? Mata 3 equations kutle घ्यायचे? That we already know that the 3 equations are nothing but the equations of equilibrium. Which are the equations of equilibrium? Summation fx equal to 0, summation fy equal to 0 and summation moment equal to 0, right? So to find the VA, we'll be having summation fy equal to 0. To determine HA, we'll be comparing summation fx equal to 0, and to find or to determine the moment MA, we'll be using summation moment equal to 0, right? So let's proceed. See, summation fx equal to 0 gives. Now let's observe the figure. Fx means horizontal forces, right? How many horizontal forces we can observe? We don't find any of the force which is acting in horizontal direction except our reaction HA. Therefore, HA equal to 0. It's very easy to understand. Now think about summation Fy, right? Fy means forces in y direction. How many forces are there in y direction? 1 2 3 4 5 6 7 8. कुणी पण सांगा किती फोर्सेस आहे y डायरेक्शन मध्ये? साक्षी, प्रेम, दीपक, तिघांपैकी कुणी पण सांगा. हाऊ मेनी फोर्सेस आर देअर इन वाय डिरेक्शन? आणि घाबरायचं नाही, डायरेक्ट बिंदा सांगायचं. रिलॅक्स, बिलकुल. येत असेल तर सांगायचं, येत नसेल तसंही सांगायचं. टोटल 7 फोर्सेस. 7. बर, आता काउंट करा बरं. 7 कुठले कुठले 7 आहे? सी
3
आर ए और व्ही ए इज युअर रिएक्शन. तो समजा तुम्ही एक काउंट करा. 3 kilonewton is second force, 1 kilonewton is third force, and this UDL is 1 force. त्याच्यात तुम्हाला 5 एरो जरी दिसत असतील तरी तो एकच फोर्स आहे, UDL. So we have 3 external forces and 1 vertical reaction. म्हणजे आपल्याकडे किती आहे टोटल? We have 4 forces, right, in y direction. मग त्याचं इक्वेशन कसं येईल? We have summation Fy equal to 0. So vertical upward direction is taken as positive. So which forces are in upward direction? Only VA is in upward direction. All the 3 forces, 3 kilonewton, 2 kilonewton per meter and 1 kilonewton, these are acting in downward direction. म्हणजे ते आपल्याला नेगेटिव्ह मध्ये पाहिजे, and VA आपण पॉझिटिव्ह मध्ये लिहिणार. मग लिहायचं कसं बघा. So VA, we have taken it positive as it is acting in vertical direction. Then 1 kilonewton downward, 3 kilonewton downward. So -1 and -3. That we have written -1 and -3. Now thinking about the UDL, UDL is 2 kilonewton per meter. म्हणजे एका मीटर साठी हे 2 kilonewtonचा फोर्स आहे. पण टोटल किती डिस्टन्स वरती आहे? इट इज फ्रॉम सी पॉइंट टू डी पॉइंट, अँड द डिस्टन्स बिटवीन सी टू डी इज 2 मीटर. मग आपल्याला याला पॉइंट लोड मध्ये कन्वर्ट करायचंय. तर कन्वर्ट कसं करणार? बिकॉज वी नीड फोर्स अँड दिस इज इंटेन्सिटी. जसे हे 3 kilonewton वी आर हॅव्हिंग, 1 kilonewton वी आर हॅव्हिंग. सो टू कन्वर्ट दिस 2 kilonewton per meter, we need to multiply that 2 kilonewton per meter to the distance over which it is acting, right? So it is acting over 2 meter and its intensity is also 2 kilonewton. So 2 kilonewton into 2 meter, कारण की एका मीटरला 2 kilonewton आहे. करेक्ट. एका मीटर साठी 2 kilonewton आहे, म्हणून तो 2 मीटर साठी किती असेल? 2 into 2. करेक्ट. सो मल्टिप्लाय द इंटेन्सिटी to the distance over which it is acting or it is spreaded. So 2 into 2, that is 4. As it is acting in downward direction, so it is minus. So what we get? So we get vertical reaction A as 8 kilonewton. मग आता आपण काढलं काय? We have calculated VA and HA. आता राहिली तुमची मोमेंट. So for the moment we need summation moment about A, right? So we have taken anti-clockwise as plus. So we have MA positive, then A means HA is passing through A point. फक्त काय लक्षात ठेवायचं? जो पॉइंट तुम्ही कन्सिडर करणार आहात त्या पॉइंटला जे कुठले फोर्सेस ऍक्ट होणार असतील ते फोर्सेस 0 समजायचे. बिकॉज VA and HA both are acting at point A. मोमेंट कुठे घेतोय आपण? A लाच घेतोय. व्हॉट इज मोमेंट? फोर्स इंटू डिस्टन्स. सो दो VA and HA are having some magnitudes, but the distance between A point and HA and VA is 0. त्यामुळे त्यांची मोमेंट 0 असते. म्हणून मोमेंटच्या एक्सप्रेशन मध्ये ज्या पॉइंटला तुम्ही मोमेंट घेणार आहात तिथे जर कोणते फोर्सेस ऍक्ट होत असतील तर ते कन्सिडर करायचे नाहीत, राईट? सो HA and VA, these two forces are vanished. Now which is remaining? We have only single moment, that is MA. मोमेंटच आहे आणि ती तिथेच ऍक्ट होतं त्यामुळे ती पिक्चर मध्ये येणारच आहे. सो वी हॅव MA anti-clockwise, so we have taken at positive. Now other than this, we have again three forces: 1 kilonewton, 3 kilonewton, and UDL of 2 kilonewton per meter. So let's proceed. What is moment? Force into distance. Simple लक्षात ठेवायचं. Force into distance. मग मेजर कसं करायचं? First, 3 kilonewton is the force. It is point load acting at point B. Moment कुठं घेतोय? We are considering or taking moment at point A. So measure the distance of the force from the point of consideration. म्हणजे मोमेंट कुठे घेतोय? ए पॉइंटला. फोर्स कुठे? बी पॉइंटला. What is the distance between A and B? It is 1 meter. So what is our expression? It is 3 kilonewton into 1 meter, means force into distance. So 3 into 1 is our expression. Now remaining is sign convention. So as we are considering anti-clockwise is plus, but about A point, A ला एक बोट ठेवायचं आणि 3 किलोन्यूटन ला एक दोरी बांधायची आणि मग बघायचं की 3 किलोन्यूटन जेव्हा असं खाली जाणार आहे तेव्हा तो घड्याळी सारखा चाललाय, मीन्स इट इज मूव्हिंग इन क्लॉकवाइज डिरेक्शन. करेक्ट? सो इट इज मायनस. सो व्हाट वी हैव रिटन? minus 3 into 1. Correct? So this is our first expression, means moment of 3 kilonewton point load about point A. 3 into 1 clockwise means minus. आता इकडे बघा 1 kilonewton. Again it is point load. Now we need distance. Which distance is required? So the distance between this 1 kilonewton and point of consideration. Moment कुठे घेतोय? We are taking moment at point A. So measure the distance between A and this 1 kilonewton, means E. So 1, 2, 3, 4, 5. So distance is 5 and magnitude of this force is 1 kilonewton. So our expression is 1 into 5. Now direction is remaining. So again, hold your finger about A point and consider this blue line or beam as a rope or a thread. And if you hold this 1 kilonewton, so it will again rotate in clockwise direction, right? So this is again with negative sign. So minus 1 into 5. This is what we have written over here. And last is our 2 kilonewton per meter. Again it is intensity. So that is to be converted into point load. मग point load कुठे ऍक्ट होणार आहे? तर जो कुठला शेप असेल त्या शेपच्या नेहमी तो सेंटरला असतो, सेंट्रॉइडला. So it is a rectangular shape. Therefore its total force means 2 into 2 4 kilonewton will be acting at the center of CD. CD is 2 meter. So its center or centroid is at 1 meter. So the 2 into 2 4 kilonewton force will be acting at the 1 meter from point C as well as from point D. But आपल्याला कुठनं मेजर करायचंय? We need to measure it from point A, right? So from point A to this center point or centroidal point, it is 1, 2 and 3 meters. So 2 into 2 is 4 and 4 into distance is 3. So 2 into 2 into 3. So that comes out to be 20 kilonewton meter. So this way we can find the support reactions. So we have HA horizontal, VA vertical and moment about A as 20 kilonewton meter. But when we have two reactions, तिथली एक रिएक्शन जी असते ज्याला आपण रिझल्टंट म्हणतो, means type of a composition of forces, that is to be calculated if required or asked. Otherwise we no need to worry about that thing. So therefore for a sake of consideration we find the resultant reaction at point A by using the resultant formula, that is under root HA square plus VA square, that is again comes out to be 8 kilonewton. So this way we can find the support reactions for any beam, but that too again determinate beam. Continuous beam आपल्या सिलेबस मध्ये सध्या नाही इथपर्यंत, युनिट 5 पर्यंत. Therefore we cannot find the reactions of indeterminate beam by means of simply these three equations of equilibrium. For that we need extra additional methodology or method that we'll study later. So this was about our prerequisite session. So at last we have second example, that is support reaction of simply supported beam. फक्त आपण शॉर्टकट मध्ये जाऊया, एकेकाने फक्त मला सांगा याला किती रिएक्शन्स असतील. We have simply supported beam, how many reactions? कुणी पण सांगा किंवा आपण एकेकाला विचारूया, कुणी पण सांगा. आणि सगळ्यांनी पार्टिसिपेट करायचं, सगळ्यांनी आन्सर द्यायचं, चुकलं तरी चालते आपल्याला. नो नीड टू वरी अबाउट एनीथिंग. Number of reaction. First question is number of reactions.
5.
Number of reaction 5. बघा number of reaction विचारतोय मी.
2.
Number of reaction 2, 3. आपल्याकडे तीनच ऑप्शन आहे. रोलर सपोर्ट, हिंज सपोर्ट अँड सिंपल सपोर्ट, सॉरी फिक्स सपोर्ट. रोलरला 1, हिंजला 2 आणि फिक्सला 3. नाउ सी सिम्पली सपोर्टेड बीम म्हणजे मी काय सांगितले तुम्हाला, एक साइड हिंज असेल आणि एक साइड तुमची रोलर असेल. सो फॉर सिम्पली सपोर्टेड बीम वी हॅव 3 रिएक्शन्स. ठीक आहे, 3 कुठल्या कुठल्या. सो ऍट ए, समजा इकडे हिंज असेल ए पॉइंटला, तर इकडे 2 रिएक्शन असतील आणि ऑफकोर्स दुसऱ्या साइडला रोलर असेल तिकडे एक रिएक्शन. ऍज नो हॉरिझॉन्टल फोर्स इज प्रेझेंट, म्हणून हॉरिझॉन्टल रिएक्शन तुमची येणारच नाही, सगळे फोर्सेस वर्टिकल आहे. सो वी आर हॅव्हिंग 2 रिएक्शन्स ओनली, 1 टू द लेफ्ट, 1 टू द राइट. राइट. सो दिस इज अवर फ्री बॉडी डायग्राम. Means 2 reactions, that is VA and VE. 2 reactions, we need 2 equations, that is summation Fy and summation moment. So as it is symmetrical, so we have 3 kilonewton each. बघा symmetrical कसा आहे, 2, 3, 4 मीटरचा बीम आहे. टोटल लोड बघा 2 kilonewton is acting at B, इकडे 1 मीटर आहे. 2 kilonewton ऍक्टिंग ऍट डी, इकडे 1 मीटर आहे. म्हणजे 2 kilonewtonचे दोन्ही लोड सेंट्रली प्लेस झाले. अँड युडीएल 1 kilonewton पर मीटर ऍक्टिंग ओव्हर बीडी, हा पण सेंटरच्याच 2 मीटरला आहे. लेफ्ट साइडला 1 मीटर सोडलंय, राईट साइडला 1 मीटर सोडलंय. त्यामुळे जो तुमचा टोटल लोड आहे, टोटल लोड इज ऍक्टिंग इन द सेंट्रल रिजन. मग सेंटरला जर लोड असेल ते कॅज्युअल आहे, और इट इज बट ऑब्वियस that the total load will be divided into 2 parts, 1 to the left, 1 to the right. पण डायरेक्ट कॅल्क्युलेशन कसं करायचं बघा, 2 kilonewton, एकचा युडीएल किती डिस्टन्स वर आहे, 2 मीटर. सो 1 into 2 झाले तुमचे 2. सो टोटल लोड इज 2 2 2 6 kilonewton. हाफ विल गो टू द लेफ्ट, हाफ विल गो टू द राईट. म्हणजे तुमचं आर ए आणि आर ई याचा मॅग्निट्यूड किती आला पाहिजे, 3 kilonewton. आणि तेच आपलं कॅल्क्युलेशन नाही येत आहे.